Alrighty, the diagram below shows the graph of the function y equals f of x. Wow, that's so helpful. What's more helpful is the graph itself. So let's have a look at that. Just looking at the shape here, I can tell that that is a cubic graph. So it is a cubic. So it might look like something like x cubed plus something else perhaps. But we know we're starting with a cubic. Alright, and the question is, on the axes below, sketch the gradient function, right, f prime of x. So a very common question where we're given the original function, f of x, and we're given the sketch, and we're asked to sketch the gradient function. Alright, before we even think about the sketch, let's just do it as we normally would if we knew the equation. So if our original function was y equals x cubed, the derivative would be 3x squared. Alright, we take the power 3, multiply it out the front, and then subtract 1 off the power. So that we expect the derivative to be a quadratic. Right, so it starts at a cubic and goes to a quadratic. Cubic to quadratic. Great. So we know our shape is going to be a parabola. However, the next part is to work out what the intercepts are, where the turning point is, and from that we need to use the sketch of f of x. Alright, so the key points we're looking for are the turning points, first of all. So that's about at what, -2 and +1, if the scale is 1 for every grid. Now, what is the gradient at a turning point? So if we were to draw a tangent line at the turning points, they would be perfectly flat, right, horizontal, because the gradient at those points is equal to 0. So the gradient at x equals 1 is 0. On our gradient function, when x equals 1, the gradient f prime of x will equal 0. So in fact, that dot I just put at x equals 1, f prime of x equals 0, tells us when x is 1, the gradient is 0. So back to our sketch up here, when x is 1, the gradient is 0, because it is a turning point. Similarly, when x is -2, the gradient is also 0. So on our derivative, our gradient function, x is -2, the gradient, right, the y value, or the f prime of x value, is 0. Awesome. So now just looking at that, do we have enough to sketch our quadratic? Yes and no. So from 2 points, the only graph we could accurately draw would be a straight line going through them. However, we know it's either going to be a parabola, something like that. One or the other. So back to the graph. Focusing on this section here, the gradient there, see how it's going up and up and up? It is a positive gradient. Right, we call it increasing. At this point right here, at -2, the gradient is 0. So 0 gradient. And we actually call that stationary. stationary with an E, not an A. It's not your pencil case. Now, after that point, how would you describe this yellow section? Is it increasing, stationary, or decreasing? Right, so since it's going down and to the right, we would say it has a negative gradient, and we call that decreasing. Again, at x equals 1, it's stationary, and then from x equals 1 onwards, it's back to increasing. So just to summarize, it goes from positive to stationary, to negative, to stationary, to positive. Now, what does that mean for us? So on our gradient function, we know between those two red dots, right, between -2 and 1, our gradient is negative. So on our gradient function, it will have to have the y value being negative, right? Something like so. However, we know on the outsides, so when x is less than -2 or more than 1, the gradient is positive. So it'll look something like so. So just to tie those two together. So, in summary, we look at the graph and acknowledge it's a cubic, so we know the derivative, right, the gradient function, will be a quadratic. We look for the turning points, and we know at the turning points, on our gradient function, those will be the x-intercept, because on the y-axis is the gradient, so when the gradient is 0, x is 1, or x is -2. The last thing to decide is it a positive parabola or is it a negative parabola? Now, just looking at the cubic, since it's a positive cubic, we know actually that the derivative will be a positive quadratic. Yeah. Alternatively, you could look at the gradient like we did. When it's green, it was positive. So on our gradient function, it's above the x-axis. When it's yellow, it's a negative gradient, so that's below the x-axis. Right? Either approach works, and to get the achieved mark, you need the intercepts correct, and it needs to be a positive parabola.